Quick review, section 2.3, real zeros polynomials. Students will be able to use synthetic division to evaluate functions, also known as synthetic substitution. Students will be able to use synthetic division to completely factor a polynomial. For our first example, we're going to look at that synthetic substitution. So this is another way of evaluating functions. So instead of taking this value of -2 and replacing the x in our polynomial and calculating it, we're going to use synthetic division. Keep in mind this is our solution as well, so when we write our synthetic division, let me grab a pen, the outside number is going to keep the same sign. Then we're going to draw an L, and we have to think before we start writing if there's any missing terms. In this case, there are no missing terms. I have an x to the third, an x squared, and an x, and a constant. So we're going to write just the coefficients, 3, 8, 5, and -7. And then what's going to turn out is that this last value here, that is going to be our answer. That's going to be the function at -2. So in synthetic division, first thing is to look at this 3, and you're going to bring it down. So it's a starter number. And then you're going to do two things. You're going to multiply and add. So we're going to first multiply -2 times 3, which is -6. Add these two, which is 2, and then we're going to repeat the process. -2 times 2 is -4. Add, multiply, and add. So my function value at -2 is -9. Next example, we need to write the complete factorization if you're given one or more factors. So I have a cubic, a third degree polynomial, and I'm given x plus 2 is one of my factors. I want to use synthetic division to completely factor this polynomial. Since we're given a factor, when we're using synthetic division, I want not to use a positive 2, but I want to use -2 because it's x minus a -2. So on the outside will be the -2. Again, we have to be very careful when we're writing it to include any missing terms. 2, 1, -5, and 2. There are no missing terms. It's just the coefficients. 2, 1, -5, and 2. And because we're told that this is a factor, our remainder should be 0. So I'm going to put a 0 in advance to make sure that's what I get. If I don't get it, then I made an arithmetic mistake. Bring down the 2, multiply, add, multiply, add, multiply, add, and I do get 0. So we started with a third degree polynomial. We factored it once. We've taken out this factor, so now we have a second degree polynomial. Well, second degree polynomial means I have a quadratic. 2x squared minus 3x plus 1. So each time you do synthetic, you're depressing the polynomial. You're decreasing the degree by 1. So third degree to second degree. Once we get to a quadratic, to factor it, we can use the x factor, whatever method of factoring you prefer. I'm going to use the x factor plus times 2 fraction bars. -3, that's my b, a times c, and the a goes underneath. I'm looking for two numbers whose product is 2 and whose sum is -3, which would be -2, -1, reduce, and that one can't reduce, so I've got my factors of x minus 1 and 2x minus 1. I think I'm putting the x on the denominator and keeping this a fraction. So now we're going to write the complete factorization. So f of x plus 2 was given to me as a factor, and then we found x minus 1 and 2x minus 1 as the other factors. So that would be the complete factorization. You can use the same process for virtually any degree. Just have to be given enough factors. So now we have a degree 4 Got two factors. Again, the numbers that we want to use are the opposite of these here. It's like we're setting them equal to 0 and finding our 0. But because the coefficient's 1, we can just take a shortcut. So those are the two numbers you want to use. You can start with either one. Doesn't make a difference. So I'm going to start with 3. Starting with 1, then negative 6. Notice on this one there's no x squared, so that's where I have to put a placeholder. 54, and then negative 81. Keep in mind that I know x minus 3 was a given factor, so my remainder should be 0. Let's go ahead and see if that's true. 1, 3 times 1 is 3. That gives me negative 3 when I add. Negative 9. Add those. Multiply 3 times negative 9 is negative 27. Add those. That gives me 27. And positive 81, and I do get 0. Okay, so keep in mind again, we started with a 4th degree polynomial. These are the coefficients here. We've taken out one of the factors. So we've divided, it's kind of like dividing out by an x. So we decreased the degree by 1. So this represents a 3rd degree polynomial. We're going to layer our synthetic. Now I'm going to use a negative 3 because it must also go into this new polynomial. I know my remainder must be 0, and let's go ahead and make sure it does. Bring down the 1, multiply, it's negative 6, multiply, it's 9, negative 27, and it gives me 0. So start with a 4th degree, 3rd degree, I'm down to a quadratic. So x squared minus 6x plus 9. And then once you factor this, becomes x minus 3 quantity squared. So we put all our factors together, the one we just discovered, along with the original 2, that gives me the complete factorization. X minus 3, x plus 3, x minus 3 squared. But if you look closely, I have an x minus 3 here, x minus 3 squared. So we're going to rewrite that as x minus 3 cubed, x plus 3. So this would have a multiplicity of 3.